Okay, good morning, everybody. Let's get started. Uh, could you see my screen?
Yes.
Yeah,
Yes,
like
sir.
yeah, homework set two. Yeah. So okay, so please turn off your mic. Um, have you noticed that I sent an email in the midnight that I already uploaded the solutions for both sets of homework set one and homework set two on the eCourseware under the tab homework. Uh, Have you noticed that? Can you see there the solutions?
Yes.
Okay, great. And then now I will go over so that you may, I believe you all have your hard work, sorry, the hard copy that you submitted through the PDF file. So you see, and then you can match with me, and then you will get the correct solution here. So first time going homework two, because this is very fresh, you just submitted on Friday. That is very fresh in your memory, and then we will go the homework set one as well. So everybody see the very first one. There are two functions, v on this number and then v to this number, and find v plus v on. So the question was that you have to sum up, add up those two. Now you cannot add up in that format. It is difficult because they are time domain function. That's why first you see what we are doing. First I'm converting into cosine. So how to do that? Because there was minus sign, so I am taking cosine and then plus 90. So then it will be minus sine this number. So you see from here I am getting omega t plus 60. So I can write V on 10 angle 60. So I think everybody understand this one. And then V2 was straightforward. It is in cosine format already. So I am writing V to 20 this angle. And then now I am summing V on this one and V to this one plus. So because these two are in polar form, so first I am converting into rectangular form. And then again this one rectangular. And then real part sum, and then imaginary part sum. And then from here I am expressing in polar form. Finally, from polar form, I am converting into time domain. So therefore, this will be the appropriate answer. So you may leave here, but because originally the function were time function, so that is what you are asked. Like v equal to v1 plus v2, you have to express in time domain. So that's why this is the final answer. So is everybody fine with that? So did you all get this result?
Yes.
Yes.
Okay, yeah. I mean, soon in a day or two, you will, we will let you know your grade for homework one and homework two. So now I am just giving you the solutions. Okay, that is fine. Number two, find the input impedance of the following circuit in figure one. Assume that the circuit operates at omega 50 radian per second. So therefore, you see, from here, you have to find out the equivalent impedance, input impedance, looking from here. So therefore, everybody see the circuit. Uh, as you can clearly see, because I am looking from here, so this will be in series, and then I am looking this point and this point from here. But then the remaining component will be in parallel with this point and this point. So that's why clearly these two are in series and these two are in series. Then this combination will be in parallel with this one, finally series with this one. Now everybody see, first you have to convert into phasor domain. First you have to convert into phasor domain, especially those capacitance and inductance, those components. So for 2 millifarad, you see, I have given the name this one like G1, like impedance of the 2 millifarad capacitor, that is the G1. Just I gave the name. So G1 is what is 1 over J omega C. And then J omega is 50, C is 2 millifarad. So I am converting into farad. So 2 10 to the power minus 3. So ultimately I got minus J10 ohm. Now G2 is this one, this branch. I mean 3 ohm is in series 10 millifarad. So you see G2 is 3 plus 1 over j omega c. This term is for this one, and then you convert 1 over j 50 omega value, and c value was 10 millifarad. So 10 multiplied by 10 to the power minus 3. Again, I am converting into farad. So finally from here, I mean, this portion gave you minus J2. So that's why 3 minus J2. Now this one, this is 8, this is fine, but you have to convert this one into phasor domain, which is J omega L. So therefore from there I got plus J10. So 8 plus J10. Now I got 3 branch phasor domain impedances. Now make their equivalent. So if you see that I have written input impedance G in. Now G on, this one is G on plus G2 parallel this on J3. So already we calculated those values. Just put there and then go ahead, you calculate. So finally you should be getting this number in rectangular form. I think I did not write the polar form. Polar form should be 11.53 and angle minus 73.78. So did you get this result, everybody? Or in the, you get this one?
Yep.
Okay. Or if you express in polar form, I mean, it will be 11.53 angle minus 73.78 degree. Okay, so this is fine. Now this one, everybody see, evaluate the following complex numbers and leave your results in polar form. So you see that first you have to make the whole operation, this multiplied by this on, then minus 5 angle 60, and then you see the bracket closed. Therefore after calculating, then you make conjugate, complex conjugate. This is the complex conjugate sign. So therefore see the first one, this one, I am just multiplying, I multiplied. From here, you know, I converted into again the rectangular form. Then I simplified. And then you see from here I have the plus sign, plus j. So what I did the minus. So that is the meaning of the complex conjugate. And then from there I got this one. So therefore this should be the correct result. This is what you are asked. It says express the leave your results in polar form. So you have to show this one. I think everybody did this one. And then the next one was 10 plus J5, 3 at an angle of 40 degree over this one, plus 10, this one, plus J5. So therefore, because there is division, so you have to actually express it in polar form, then you can divide. That's why first, you know, I keep this one as it is. I converted this one into rectangular form. And then I am operating, denominator is still the same. I am going. And then I converted this one into polar form. This one converted into polar form. Now I can operate. I just divide this one, 2.84. This angle will go in the numerator, that will be subtracted. Then minus 97.47 plus this one plus J5. Then in the next line, again, because I have to sum up, so I converted this one into rectangular. I converted this one into rectangular plus J5. And then just calculate. I got this one, and from here, this is the final result, 10.97 angle 40.9 degree. This will be the correct result. So did you all get this number?
I did not, but I was wondering, was my mistake? I did everything converted to polar, and then converted to rectangular only at the very end.
So So you said that you did everything in polar form and then later you converted into rectangular?
Yeah. Could that have messed it up?
Yeah. How did you sum up the polar thing?
Um,
Is it through your calculator?
yes.
Oh, then maybe somewhere there is mistake. Your
Okay.
your calculator did not help you. Maybe somewhere. So therefore, when doing calculator, please be careful. You see, I mean, I am showing you the result. I mean, step by step, how I did. So the best thing to do is that you convert polar into rectangular when you are making summing or subtracting. That is the best thing. So you see, that's why, I mean, instead of converting this one into polar, I change this one into rectangular. Because you see, then you can easily do. So 10 plus 2.3, 12.3. And J5 plus J1, J6, 9.3. And then I left. And then because you see, now this is division operation. So you have to convert into polar. You see that both numerator and denominator, I converted into polar. So what is the benefit? I just divide this number by 5. It gave me 2.84. And then because this is division, angle will be subtracted. This minus this one. So that's why I got minus 97. And then still this is same, this is same. Now because I have to sum up, now I need to convert into rectangular. You see? And then you sum up all real number. This is real, this is real, these two real, I got 8.29, and sum up all imaginary part. This is J10 minus J2, so J7 point. And then convert at last into polar. So this will be the the appropriate or the best approach. So therefore, everybody, when you are using your calculator, please be sure that you are properly converting and your calculator is giving you the correct result. So otherwise, you try yourself in that way, step by step. Is everybody fine?
Yes.
Okay, great. Okay. Now look this one. Yes, this is the, I think, most wanted problem that you are asking. I mean, soon in a day or two, we will be evaluating and letting you know your date, but look, so what I did. So everybody see, look this one, that top, this node, this portion, this low. This is a delta. You see, between A and B, there is on component. Between B and C, there is on component. And between A and C, this is on component. I mean, in series form, 2 minus J4. So that's why first you have to convert into Y. So this means between AB and between AC, I mean, between these two, you will get on component. Between this one, you will get on component. And between this and this branch, you will get on component. So you see here, I just gave dot line. You see, I have assumed, okay, this is endpoint. So I will get on this line, GEN, I have given them. From here, I will get one. From, between these two, I will get this one, GCN. I have given the name. And then I am calculating. So I think everybody, let me take you for a moment. Just a moment. Okay, just an example. This is delta, right? Yes. For example, A, B, and C. And then this is R1, this is R2, and then this is R3. This is in delta format. Now you have to convert into Y. So what you will do, from here you will get on point, and then there will be one here, and then there will be one here. So for example, give the name N. Now what will be this value? This RAN. So RAN will be multiplication of these two. So, sorry, R1 multiplied by R3. And then in the denominator, R1 plus R2 plus R3.
It doesn't make a difference on the numerator whether it's R3 or R2.
And no, I am coming that point. So no, yes. So when you are finding this one, you see between these two, it is easy to remember. When you are finding this one for the y, then you look what is with both side. So its both side is R3 and R1. So you must do R1 and R3. So when you are calculating this one, and then if you do R2, R3, then you will get wrong result. So therefore, let's see what I am doing. Then for example, everybody see the denominator is, for example, the result is K, R1 plus R2, R3. Now what will be this one? Everybody look, this one, RBN. So therefore, because I am doing this one, so what is on both sides? Both side is this one, R2 and R1. So R1, R2 will go here. R1, R2, and then denominator this K. I mean the sum of all these three. This one. And then what will be this one? RCN. So everybody see. So therefore RCN, this will be when I am doing this one. So this means I have to multiply these two, R2, R3. Sorry, R2, R3. And then over K. So I think you all have learned these things, how to convert Y to delta and from delta to Y in the DC circuit. So everybody, could you follow me what I did? So therefore, you see, it is easy to remember. When you are finding this one, then you just look what is its right side and left side on either side. So on either side, this is R1, this is R3. You multiply those two. And in the denominator, sum of these three, this plus this plus this. Then when you are finding this one, what you can see on both sides, R1, R2. When you are finding this one, what is its both sides, R2, R3. In that, it is easy to remember. So everybody, could you remember this one from your DC circuit knowledge?
Yep.
Yeah. So exactly, you have to apply this on there. So now I am going back there. You see, now come back. Just I gave dotted mark here, just to understand. This means I have given the name from this point GAN. This means from this one and this one, you will get this one. So by using this one and this one, you will be getting on here. And from this on and this on, you will be getting another one. So therefore, see, I'm converting delta to Y. So GAN, what will be my this value? This value will be this one multiplied by the series combination of this one. Therefore, see my calculation. J4 multiplied by this one, 2 minus J4. And in the denominator, the sum of all these. This means you see J4 plus 2 minus J4 plus 8. And then see my calculation. I am just multiplying. So you see this is J8, this is J8, and this one J squared 16, and J squared is minus 1, so minus minus plus 16. And then you see denominator plus J4 minus J4 cancel, 8 plus 2, 10. And then I just simplified, I divide by 10. So from here I am getting 1.6, from here 8 divided by 10, J 0.8. I mean, for this one, you don't need even calculator to calculate this one. And then see this one, GB1, next one. So what is it, both side? Both side was this one, this one. So you have to multiply these two, J4 multiplied by 8, you see? And what will be my denominator? Denominator, I got 10 here. Again, sum of all those three. The same number will go denominator. So and then again, this is 32. I am dividing by 10. So J 3.2. The same thing for GCN. When you are finding this one, 8 multiplied by this one. I mean the series combination of this one. Therefore see 8 multiplied by this one, 2 minus J4. I did, and the denominator 10. So again here I am getting 16 minus J32 divided by 10, 1.6 minus J3.2. So everybody understand this calculation? Is everybody fine?
Yes.
Yeah. So then see, once you do that, then see I have drawn a new diagram. I have that Gn. You look, my Gn was from this point to this point. I just gave a name, this point n. So I have given the name Gan to represent this one. So this means in this circuit, this is source and then 12, and then I will be getting this one, and this one. And then this will remain as it is, this will remain as it is. So you see, exactly I am doing that one. G1, this is endpoint, this is GBN, and that on in series, I mean that this one, and then this one and this one. Now everybody see, this thing, whole thing is in series, GCN plus this one, and then GBN plus this one. And after doing that, then this branch is in parallel with this one. Then this combination is series with this one, series with this one. That's all. So the total impedance, you see, I have written G, this 12, plus this one, and then parallel combination of, I mean this one, GBN minus J3, parallel, this is parallel sign, GCN plus J8 plus 8. And then if you just manipulate, then finally you will be getting Z value in polar form 13.64 angle 4.204 degree. And once you get that total impedance, then you are done. This is your voltage. You are asked to find out the total current. So therefore total current, you see here I have did V over G. So this V is this V, 50 at an angle of 0. And what is my G? This is my G. That I put. So the final result is 3.67 angle minus 4.204 degree ampere. That is the correct result. So could you follow me, this thing?
Yes.
Yeah. So therefore now, because everybody you have submitted and then you have your hard copy, so you match that where you made mistake, and then accordingly you see. So therefore this is the only part, important part, converting delta to Y. So therefore you just remember your past knowledge in DC circuit. Exactly same thing we are doing. Only difference, in case of DC circuit, you only notice the resistance. Here you are looking the reactance, inductive reactance, capacitive reactance. It is, you are looking here in the impedance part. That's only the difference. But the rule is the same. Same thing equally applies here. Okay, I think everybody. So therefore, again, like I will be asking you one similar question in the midterm exams or the final exam. Again, similar things. Yeah. So a little bit different format. So that time you have to do it correctly. So everybody, again, like please understand after the class, I already uploaded the solution on eCoursera. So again, you have chance. Okay, so moving forward, look this one. Calculate V naught T in the circuit of figure T. So this means that the first of all, this is time domain circuit. First you convert into phasor domain. So this is the phasor domain circuit from here. So how to do that? This is 20 cosine of this, so 20 angle minus 15 degree. And then resistance is fine, this is 60 ohm. But you have to convert these two, I mean inductance and capacitance into the phasor domain. So how to do that? For 10 millifarad, this is capacitor. So for 10 millifarad, what is minus jxa or 1 over j omega c? I directly put minus j, minus j 1 over omega c. What is my omega? This is 4 is omega because cosine omega t. So I got 4 here, and c, what is c? 10 millifarad. I converted into farad. So I got minus j 25 ohm. Now convert this one. sorry, this one, 5 Henry. So for 5 Henry, it is J omega L, you know. So J omega 4, this L is 4. So J20. So that's why that J20 is placed here and minus J25 is placed here. So this is the phasor domain circuit. So therefore, when the circuit is in the time domain, that is the very first task you have to convert into phasor domain. That is the very first step that I did. So your question is find out the voltage across this one. So everybody see, if you know what is the current flowing through this branch, then you are fine, right? You just need to know what is the current flowing. And then you will be multiplying by the respective impedance. This means how much current is coming, that current multiplied by J20. That will be your V0. That's all. So therefore now you see, by looking this circuit, this is the voltage value. First you find out the total current. What is the total current flowing through here? So if you can find out the total current flowing through this branch, and then look everybody, that current is going here. Then after coming here, some portion is going through this one, something is going through this portion. You have to find out this current. That's all. So therefore, once you can find out what is the total current flowing here, and then you apply the current divider rule. You apply the current divider rule here. So you all know. So therefore, let's look. So therefore, to find out the total current at first here, first find out the total impedance. What is the total impedance? This means this is in parallel with this one and series with 60. So you see, I am doing ZT total impedance, this 60 plus parallel of this one. So how to do parallel? This multiplied by this and divide this plus this. And then I am calculating. I got the GT value in polar form 116.62 angle 59.04 degree. And once I do that, then I am finding a total current for this circuit. So what is the total current? This voltage divided by that impedance, total impedance that I got. See, I am doing that one. So I got, this is my total current. And once I got the total current, as I told you, your goal, your target is to find out how much current is flowing through this branch. Then you are done. So here the total current is entering at this point, and then I am applying the current divider rule. How to apply current divider rule? Total current multiplied by this one, divide by this plus this. Current divider rule. So therefore I am applying current divider rule. Sorry, here. IJ20 ohm. I want to find out current flowing through this one. So that's why I gave the name I subscript J20 total current, you see, multiplied by other impedance. When I am finding current for this one, I have to multiply this one. If I want to find out current this branch, then I have to multiply with this one. You all remember, you can revise your current divider rule. So that I am doing. And then in the denominator, sum of those two. So finally I got 0.85 angle minus 74.04 degree. And then once I got this current, multiply with this one. That will be your voltage here. So everybody see, just I am multiplying J20 multiplied by J20. So finally I got 17 at an angle of 15.96 degree. This is approximate, I think 17 point something. It was very small number. So I neglected that one. Just I rounded it 17, this one. And then finally convert into time domain. So Vt 17 cosine of 40 because omega was 4 plus this angle. I am done. So did you all get this result?
Yes.
Okay, great. Yeah. So therefore, you might do different way. You might apply, that loop, and you might apply nodal thing or other way you might do. So I just did this way. You may not necessarily have to follow exactly the same thing, but you must get this result. Whatever way you do, results should be the same. That's the key. Everybody, could you follow me what I did? Do you have any questions, comments? It's just, you know everything. It's just a matter of calculation. So you have to little bit attentive and you should have patience while doing calculation. You see, I mean, I am just showing you how I did it step by step here. Anyway, so now moving forward, number 6, calculate V naught in the circuit of figure 4 using the superposition theorem. So left side there is a voltage source 50 sine of 5t. Right side there is a current source 4 cosine of 10t. And this is 1 Henry 0.2 farad capacitor 8 ohm. So you see plus minus V naught. So you have to find out V naught. So therefore, you all know, because this is superposition theorem, you have to consider the effect of one source at a time. Therefore, first assume that this source is present and then find out what is the voltage. Next, consider that this source is present, this is absent. Then with respect to that, find out the voltage across this one. And then at the end, you just sum up those two voltage. That's all. So therefore, you see what I am doing? When voltage source is present, meaning that first I am assuming this is present and this is absent. That is my guess. So what is the meaning of absent? Absent means because this is current source, this will be open circuited. You all know. And when you will be considering this on, this source is present, this is absent, this is voltage source. So absence means this will be short circuited. So you know those things. So you see, when voltage source is present, so first you have to convert into phasor domain. This is time domain function, time domain values. First you convert into phasor domain, everything. Now source, you see, it was 50 sine of 5t. So I am converting into cosine. That's why I got 50 minus 90, 8. And then I converted this on. So you see that this is the calculation. 1 over j omega c, 1 over omega is 5. You see this is sine omega. So omega is 5 and c value is 0.2. So I got minus j1. That's why I wrote here minus j1. And then for this one Henry, I got the j5 because omega is your 5. So therefore j5. So therefore this is my circuit. Now based on this circuit, find out what is the voltage here. So therefore everybody see what I am doing. First I am doing total impedance. What is total impedance? These two are in parallel. I am making parallel calculation plus in series 8. So then I got, this is the total G, 8.10 angle minus 8.88. And then I am finding total current here, total current. And once I get the total current, I just need to find out the current flowing through this one, because I need to know how much, what is the voltage across it. So you see, I am doing that one. This is my total current. So total current divide by that one multiplied by J5. I am applying current divider rule for this one. So I am multiplying by this one. So I got that current multiplied by minus J on this one. So do you understand? Here I am applying the current divider rule. Look, this was my total current, this one. And then I want to find out the current flowing through this one. That's why I am multiplying by this one, J5, and I am dividing J5 minus J1, you see. And then this is that current multiplied by that impedance, minus J1. So that will give me the voltage here. So that is my V naught prime. So therefore, after calculating, I got this on 7.7125 angle minus 171.12 degree. So therefore, from there, I am writing V naught prime in cosine format in time domain. But because that on in actually the sine function, so that's why I converted this on into again sine function. You may not need to do this. You might not do. I just did this one. So again, from here, I am converting into sine plus adding the 90 degree. So then I got this one. Now, this is fine. Now we have to consider that this source is present and this is absent. This means this will be short circuited. Now you see, next, when current source is present. So I converted 4 at an angle of 0, and then omega value was 10. Everybody see the circuit, 4 cosine of 10 t. This means omega value is 10. Here omega value was 5, but here you have to use omega value 10. And then you convert this component into their phasor domain. So look, I did that one. I got J10, I got minus J0.5. And then now you see what you have to do. Your goal is to find out the voltage here due to this source. So what you have to do, if you can find out how much current is flowing through this one, and then that current multiplied by this impedance, that will be your voltage. So now this is current. So current is, you see, this is total current. So this current is going here, something will flow through this one, and then remaining will go this way. And again, after going there, this current will divide into two parts. Something will go there, something will go there. You have to find out how much current is flowing through this one. So that's why what I am doing, first I am making the parallel combination of these two. You know, these two are in parallel because this is on and this is other branch. So I got this parallel branch, and now I am applying the current divider rule. I want to find out current Ix. I have given the name that this current is Ix. So total current multiplied by this one, divide by this plus this one. So, and then I got this on my Ix. So therefore, again, I have to apply the current divider rule here because I want to find out current through this branch. So again, current divider rule. So Ix multiplied by this, divide this plus this. So exactly I did that one multiplied by it over this one. And then once I get that current, multiply by that impedance minus J0.5. So finally I got V naught double prime is this one. And then I converted into cosine, V naught double prime. So therefore, you know, previously I got this one, V naught prime, this one, and now I got V naught double prime. I am applying superposition. Just I will sum up those two. So just that plus this. That is your answer. Everybody, could you follow me?
Yes, Professor.
Yeah. So just again, like long calculation, and you just be patient and just look at that. That's all. Okay, this one. Find the Norton equivalent circuit at terminals A to B for the circuit in figure 5. So you all know that what is the meaning of Norton equivalent? So this is the terminal AB. This means, Norton means you have to find out the current flowing through this one. If you make a short this line, how much current will flow through there due to this source, and you have to find out the Norton equivalent impedance looking from this side. And if it is current source, that will be open. If it is voltage source, that will be short. That is the meaning. So, and then everything, you know, they are already given in phasor domain. So you don't need to do anything with the impedances. So therefore, first you see, I am finding Norton impedance. In case of Thevenin, it is Thevenin impedance, you know. So GN is, everybody look, because I am looking from this side, your one eye is here, your other eye is here. You are looking from this side. So what you are looking? You are only looking this one, G10. This means whatever the number of components, everything will be in parallel with this one. That is the very first thing. I mean, sometimes like students make mistake. They think, okay, these two in series. That is wrong. You are viewing from here. You assume that you are looking from this side. So you are looking only this point and this point, meaning you are looking this point and this point. So therefore, whatever the remaining component, remaining combination will be in parallel with this one. That is the key. So therefore, because this is current source, this will be open circuited. So these two will be in series. So that's why I see my calculation 8 minus J5 is in parallel with J10. And then I got this one 10.004 angle 26 degree ohm, which you can say like J Thevenin. Now, how to get the current this one? You have to find out current flowing through this one, provided that you make a short circuit. So this means you just connect A and B. This is short. So making short, this means you are making short this J10. So this means J10 is going sorted out. So therefore, this is your total current. This current is going, something will flow this one, remaining will go through this one. So ultimately, you have to find out how much current is flowing through J5. Then you are done. That's all. Just apply current divider rule here. So you see, so IN for total current, I am finding current flowing through this one. So I have to multiply by 8. I did. And then sum of those two, 8 minus J5, 8 minus J5. That's all. So I got 3.393 angle 32.005 degree. I mean, you can leave 32 degree. Did you all get this result and this impedance value?
I messed up on the resistance calculation, so
Okay.
Yeah.
Now, could you follow me? What I was emphasizing?
Yeah.
So maybe you made series these two, right? Yeah.
yeah, I did. That was it.
Yeah. Many times. I mean, I think the last year fall when I was teaching this course, similar problem. The student made that mistake, but when I explained, then they remembered. You see, you all have learned, I mean, similar things in DC circuit. So therefore, you have to think that is the significance of this point, terminals A, B, meaning that you think that from binocular you are looking, your one eye is here, other eye is here. And then if you just keep eyes here, what will you see? Can you see this thing? No, you can see only this point and this point. Only these 2 points will be visible, meaning that whatever the remaining thing, that is in parallel. I mean, whatever the series parallel this size, that does not matter. At least the remaining components are in parallel with this one. That is the key. So that's how you have to start from here. That's why these two in series and then parallel with this one. I think now everybody understand. Therefore, what I would recommend you, like time to time, you need to go back, you need to look the rules that you have learned in DC circuit. I mean, exactly same thing. Kirchhoff's voltage law, Kirchhoff's current law, current divider rule, voltage divider rule, delta Y conversion, Y delta, superposition, Thevenin, Norton, maximum power, everything is the same. I mean, nothing new, only and only difference. Here it is phasor domain or time domain. That is the thing only. The rule is the same. Okay, then moving forward, this one. At omega equal to 10 to the power 3 radian per second, find the input admittances of the circuits. Now you see, now you are looking from here. Now looking you are from here. So therefore, when looking from here, what you will be noticing? Definitely you are noticing this one. So therefore, definitely this thing will be in series with rest of the component. That is the meaning. Same thing. When your eye is here, one thing you are looking here and here. Definitely you are looking this one. Therefore, this thing will be in series with rest of the combination, whatever the combination is. Do you understand what I am saying? Yeah. That is the key. Now this one you see, definitely these two are in series. Everybody see. To calculate the admittance, first you find out the impedance. That is the easiest way to do. First you find out the impedance. and then you convert back into admittance, y equal to 1 over g. So therefore you see, these two are in series, and then that series is in parallel with this one, and then that is in series. The same thing here. These two are in series. Everybody look, these two are in series, and that is in parallel with this one. And again, that combination is parallel with this one. And then the whole thing is series with this one. So, but first you have to convert by using this omega value into the phasor domain circuit. These all are in like a millihenry or farad value. So first you see, I converted into, I am dealing the first circuit first. I am converting into phasor domain. You see, for 20 millihenry, I got this on. For this microfarad, I got this one. And then I am making G equivalent. 60 plus, this is in series, parallel this one. I am doing that one. And then I got this one. But I have to find out y in. So y equivalent is 1 over G equivalent. So just 1 over this means this will go in the numerator, this will be denominator. Then manipulate. The unit is in Siemens or mho. So I changed into millisiemens. So the result is in millisiemens. I mean, you might live in this format or in this format. It does not matter. I just showed both format, both polar and rectangular format. Everybody, could you follow me? Do you have any questions, comment? Is this one fine? And then look the next one. Again, I am converting this one into the phasor domain. Look, and then what will be my G equivalent? This one plus these two are in series, parallel with 60. So 60 parallel this one, and then whole combination is parallel with 30. And then I am manipulating. G equivalent this, Y equivalent is 1 over G. So again, I expressed in millisiemens. This is in polar form, this is in rectangular form. You might express in Siemens only, that is also fine. I just put the number in millisiemens. Is everybody fine?
Yes.
Do you have any questions, or can you understand where you made mistake? So everybody just compare with your hard copy that you have, that you submitted for the homework, and then you will find out where you made mistake. So therefore, don't start this way. Don't think that this is in series. Everybody say, don't assume that this thing in series, these two. So only this one will be in series with the rest of the component. So therefore, when you are giving your eyes, therefore clearly you are, because this component is here, therefore this thing will be in series with the rest of the component. So then you have to start from here. This two in series, parallel with this one, that is in parallel with this one. The same thing goes for here. If you add this one and this one, that is wrong. When you are giving your eye here, then you are looking this one. So this means this is in series with rest of the component. So that's why you have to start from here. This one in series and then parallel with this one, and that combination is series with this. Okay, so if you don't have any questions, then I want to stop this one. Again, like because I already uploaded, so you have chance to look. And again, if you have any further questions, confusion, then anytime you are most welcome. You could email me or ask me next time. So I am stop sharing this one. And I think there was one more. Okay. Okay. Everybody, can you see homework set 1?
Yes, sir.
Okay. So now I will quickly go over. We don't have much time, but I will quickly go over. You see, the first question was, for the following circuit in figure 1, what value of C is needed to make the response underdamped? with unity power factor alpha is 1. So therefore you see this is parallel circuit clearly. But there are two capacitors here. So this is R, this is L, but two capacitors. So you all know these two capacitors will be added because they are in parallel. That is the rule of capacitor. Now clearly it says alpha is 1 for the circuit. So and then for the parallel circuit, the damping coefficient alpha is 1 over 2 RC. That is given, which is 1. So and then what is my 2 RC? This is 2, this is R value 10, and C is C plus this one. So I did C plus because 10 millifarad this one. And then from here you just find out C. So the result is C is 40 millifarad. This will be the correct result. You might express in farad, but this is 40 millifarad. I think everybody you are able to do that, right?
Yes.
Okay. The next question, the switch in the circuit of figure 2 has been closed for a long time. The switch was closed and it is opened at t equal to 0. Then determine I0 plus, V0 plus, di by dt 0 plus, dv by dt 0 plus, I infinity, V infinity. So I infinity, V infinity, V, very long time. After a long time, the transient has happened. That is the meaning. Now everybody say, looking this circuit, I mean I0 plus, V0 plus, before opening the switch was closed. So then what happened? This inductor was short circuited and capacitor was open circuited. Everybody look the circuit. Before opening the switch, this was open circuited. And then this was in short circuit. So this means in the circuit there was 12 volt, 4 ohm and 2 ohm only. So this means 4 plus 2, 6 ohm. So 12 divided by 6, that is your how much? 2 ampere. You see I did here. That is, and that is the I0 plus also 2 ampere. I0 minus equal to I0 plus, which is 2 ampere. You see. And then you need to find out the V0 plus. So this was open circuit. So finding the voltage here means finding the voltage across 2 ohm. So therefore 2 ampere current multiplied by 2. So it gave you the 4 volt. You see, that is V0 plus equal to V0 minus. So therefore you all know. Now easily you can find out I infinity, V infinity that I did at the very first. Everybody see? The switch has been opened at t equal to 0, the statement says. So this means that this branch got disconnected and then transient happened. So then after a while at infinity time, very long time, again this will be open circuited and this is short, but then it is open circuited means no current is flowing. This means I infinity will be 0. And then if you have to measure the voltage here because it is open circuited, what voltage you will be getting? Just 12 volt. That's why 12 volt. Therefore, you got the 4 answer easily, even you don't need the calculator. Just by mental math, you can do these 4. Now, these two are the important, di0 plus over dt and dv0 plus over dt. Right after the transient happen at t equal to 0 plus. That is the important. So therefore, you see what I am doing. I am doing IC0 plus equal to C dV by dt. You see that once the transient happened, this means current is flowing. The switch is opened, this means transient happened. So now current is flowing. And that you have to find out di0 plus by dt. And you have to find out the voltage, that is dv0 plus by dt under transient condition, during transient. So IC C dV by dt. So that you have to find out dv0 by dt, IC0 plus over C. What is your IC0 plus? Which is 2 ampere. Which is 2 ampere? The current at 0 plus. Because the same, this is series circuit. When it is opened, 2 ohm is disconnected. This is your series circuit. So the same current is flowing. So that's why I0 plus 2 ampere, that is your IC0 plus. And then 2 over C value was, I think, 0.1, 0.1 farad. I'm dividing, I got 20 volt per second. Unit will be volt per second because dV by dt. And then I have to find out di by dt, 0 plus. So what is VL 0 plus? VL is L di by dt. You see, once transient happened, what is the VL across this one? VL L di by dt, 0 plus. That I am writing. And then what I am getting? Di 0 by dt, which is VL over L. Now what is my VL? That VL is 0. So how I got that one? Now in this circuit, apply the KVL, Kirchhoff's voltage law. In this loop, apply the KVL. So therefore, if you apply KVL, this means, because this is minus to plus, this is plus minus, plus minus, plus minus. So that's why I have written by KVL minus 12. Everybody see? Plus 4 multiplied by 2, 4. What was my current? Which was 2 ampere, I0 plus. That's why you see 4 multiplied by 2. I just left as it is, VL0 plus. What was my voltage? Plus 4, which is this one, V0 plus 4 volt equal to 0. So therefore from here, you see 12 is going there, 4 times 2, 8, plus 4, 12, so minus 12. So VL plus is 0 volt. I substituted that VL0 plus here. And then I got 0 over 0.25 L value, 0 ampere per second. So this means my di by dt 0 plus is 0 ampere per second. So therefore, that is my final result. I0 plus 2 ampere, V0 plus 4 volt, and those two, and then I infinity 0 ampere, V infinity 12 volt. Did you all get these results? Or you did something different?
I got those results.
Oh, okay, okay. Okay, so then quickly this one. A load is modeled as a 250 millihenry inductor in parallel with 12 ohm resistor. A capacitor is needed to be connected to the load so that the network is critically damped at 60 Hz. Calculate the size of the capacitor. So therefore, definitely that 20 millifarad is in parallel with this one, 12 ohm, and you are connecting a capacitor to the load so that the network is critically damped. So therefore, this is parallel circuit. You find out alpha, find out omega naught, and because it clearly says critically damped case, so this means alpha equal to omega naught. You just equate those two. And then plug in the numbers, you will be getting C value 0.434 millifarad or 434 microfarad. I just expressed 434 microfarad, but you can express in farad or millifarad, no problem. Everybody, could you follow me?
Yeah, but what about that part that says critically damped at 60 hertz? What does that have to do with the question, if anything?
Joe, you don't need to do anything with that one. So
Okay.
this is the meaning that, okay, this was the normal frequency.
Oh, okay.
Yeah, it is just the normal, typical situation. Even the frequency is not mentioned, that is fine. Okay, that is fine. Then this one, this is also straightforward. For the circuit in figure 3, calculate the value of R needed to have a critically damped response. So first of all, these two meaning the grounding. So therefore, this is the meaning that it is connected. It is connected. So therefore, once you make the parallel of this one, this will be a series circuit. Everybody keep in mind, this is the grounding symbol, meaning that this is connected. So this is a series circuit. So therefore, first I am calculating R equivalent, 60 multiplied by R over 60 plus R. And then because series, so I'm finding alpha, R over 12. I am writing omega naught expression 1 over root over LC, and then again critically damped case, critically damped response. So alpha equal to omega naught. And after doing that, I am getting R equal to 120 ohm. Just it is the matter of calculation. So everybody, is this fine? I
Yes.
think these are pretty easy. You just look, then you'll be fine. Okay, for this one, the circuit in figure 4 has reached at a steady state at t equal to 0 minus. If the make before break switch moves to position B at t equal to 0, then calculate IT for t greater than 0. So everybody see, initially the switch is here. This means this portion is fully disconnected initially at t equal to 0 minus. So therefore, first find out the current. Initial conditions are not given. You have to find out initial condition. Initial condition means finding the current flowing through inductor and finding the voltage across capacitor. So, but capacitor was not connected, before at t equal to 0 minus. So that's why capacitor voltage is 0. And then what is the current here? Just 50 over 10, so 5 ampere. So that is the very first things I see. V0 is 0 volt and I0 minus is I0, 50 over 10, 5 ampere. I am done. And then once you switch moves from position A to B, then this is in series circuit, RLC. You see, after tangent happen. So therefore alpha is your R over 12, find omega naught greater than. So this will be your result under damped case, and then put that on and then move forward. Like similar thing we discussed in the class. So you'll be getting this result. So we don't have time. I mean, soon I'll be closing the class. So you just look the calculation, and then if you have any questions or any confusion, then you will let me know. So everybody, could you follow me? What I'm saying?
Yes.
Yeah. Just you look, everything is done there. You just look. I think it is already 10:13. So maybe some of you might have the next class. So I'm just closing the. You just look everything. Everything is done. Read the statement, what things are given, and accordingly you follow. Keep in mind this is omega d. This is not omega naught. This is omega d was given. Keep in mind 30 radian per second. You see, I have written omega d 30, not omega naught. Okay, and then again look this one. Then you keep going, you will be understanding everything. So therefore you just look, and then if you have any questions, so you might email me, or again you might ask me in the next class. Okay, so is everybody fine? So therefore you all got, and then soon in a day or two you will know your grade for homework 1 and homework 2. So when it is ready, I will let you know. Yeah. Just ahead of time, I showed you the solution. So everybody, please try your best. And then next class, I will be discussing about the first midterm exam. I think your first midterm exam is scheduled on coming Monday, September 21st. So next class, at the beginning, I will be discussing about the midterm exam, or what type of question you will be asked, about the timing, how to upload on the Dropbox, etc. At the beginning of next class, I will be discussing those things. With that, I am stop sharing. Do you have any questions or comments